Hello, we're back here at Gorman Rupp at the priming tower, and we're looking at vortexing today. We're going to set up a scenario where vortexing is going to show up in our wet well. Now, with the open tank and our ability to get right down here at the water level makes it easy for us to see vortexing in the wet well. And we'll talk about a couple of scenarios. First of all, we have a glass suction line here, and then we also have an increaser that I can slide down onto the bottom of the suction line that basically gives us a flare, which will basically slow down the inlet velocities and correct some of our vortexing problem and get it to go away. And then I'll remove that increaser, and then we'll see the vortex start to show back up. So first off, we'll go ahead and start the pump, get it primed, and we'll keep our eye on the wet well to see when the vortex starts to occur. We have pumped the wet well level down to a situation where the vortex does show up pretty quickly. Keep our eye down here in the water. See it starting to form right in this area over here. See the swirling action of the water. We can even see up the suction line. If you look up the suction line here, you can see that vortex working its way all the way up the suction line back into the pump, where atmospheric pressure has now forced its way through the surface of the liquid and is working its way all the way up into the pump casing. And the pump's going in and out of a prime, partial prime. It'll lose the prime for a second, then pick it back up. Now, if I drop an increaser or a flare on the end of this suction line, we can get most of that vortex to go away. A lot of the action working its way through the surface of the liquid can be eliminated with a flare. If I remove the flare, we'll start to get large gulps of air. Pump completely loses prime at this point. Handles the air, goes back into a prime, and the vortex comes right back. You can see that vortex working its way all the way up the suction line into the pump casing. If I remove just a little bit more water out of our tank here, the vortex will become even more pronounced. Now, this is a scenario that a lot of times will show up at the end of a pumping cycle as you're pumping down to an off level. If the pump wet well is not designed with enough submergence for the suction line, vortexing can show up. It's a factor of the flow of liquid, the gallons per minute, the size of the suction opening. So when we were able to increase and put that flare on there, we actually slowed down the velocity of the liquid, eliminating the vortex almost to some degree, and allow us to pump down a little bit further with our wet well level. So in applications where an operator can go out and change their off level very quickly at an operator interface or other mechanism of that sort, they can change the off levels inadvertently down to a level where vortexing will show up and not have the minimum submergence required to keep that pump operating the way that it should. So there's a calculation of flow versus the diameter of pipe, and will tell you how much submergence that you need for a given flow rate and a given pipe size. But if you do not have that enough submergence, then the vortexing is going to show up and can cause your pump to completely lose prime. And that concludes this portion of our demonstration on vortexing.
For more information on pump hydraulics, equipment, or application engineering, watch Gorman Rupp's YouTube channel and visit us at grpumps.com.